Hi.
Vaish. Hey, I got a
How-
question for you.
Okay.
Are you in the neutral zone?
Yeah, I'm a part of the neutral zone.
I was just being funny.
Oh.
I don't even know what that is. I just saw anyway.
Yeah, that was really funny.
That's not, are you being sarcastic?
No.
Oh, you should have been. Because you didn't laugh, you didn't get it, so it's not funny, Vaish. It's not funny. All right, so what are we doing? You want to continue with the slides today or what?
I think, yeah, and also maybe could focus on like the graphs again.
The graphs again. Okay. So, like I said, they don't, okay, I'm going to share my screen. Like IB doesn't have a lot of problems to have you actually graph it. So I'm going to write my own, okay?
Okay.
All right, and see if you can do it. Maybe you can tell me, or you're doing your own sketch, right?
Mm-hmm.
And you're telling me what to do along the way, okay? Okay, so, oops, let me just do this to move you over, which you cannot see. And so we are going to have so much fun graphing y equals 4 times the sine of 2 times x minus pi over 3 minus 1. So that's the whole shebang, man. Everything's in play, right?
Yeah.
Okay, and we'll just go from 0 less than or equal to x less than or equal to 2 pi. We'll do that.
Mm-hmm.
Okay, so you're gonna do a an axis, right?
Mm-hmm.
And since we're going to 0 to 2 pi, we really don't need, well, thank you. Something just popped up on my screen that you can't see. So what are we gonna do?
Then draw the x-axis.
Okay, good. And I don't know, you're the boss unless you want me to go back through it again.
Okay. So I guess I'd start with drawing like the x-axis, and then first like drawing like the basic sine curve.
Okay. Now, are you thinking or are you repeating what I said? What I said?
No, I'm thinking.
Okay, good.
Just do like a quick sketch, like a little like dotted line thing.
Okay. So you want to go 0 to 2 pi with it?
Yeah.
Okay. Oh, I put 24. That makes no sense. Could I get a drink as well? Could someone bring me a drink? Oh my God. See, I think I'm really funny, but I don't know.
My dad's feeding our dog, so.
Okay. For a millisecond, it sounded like you said my dad's eating. That's what I thought you said. And then you said your dog, and I said he's not eating the dog.
Yeah,
He's
no,
not.
he's feeding.
But for a flat.
Yeah.
All right. So now I made myself a bigger y-axis because I'm looking ahead to the amplitude, right?
Yeah.
And we got to move some things. So I know I need a little bit of room. Am I right?
Yep.
All right. So are you just watching me and telling me what to do? Is that what's happening?
I think so, yeah.
Okay. I'm just asking because I'm not sure if I should be waiting for you to finish that sort of thing. Okay. I don't care. It's you know how you learn. Okay.
Okay.
So how would I sketch this?
So start from the origin.
Yep.
And then, wait, is that line that you drew like 1? Like, is that?
Yeah. Sorry.
Okay.
This is 1 and -1. Yes.
1 and -1. So the period is 2 pi.
Yep.
So draw like the maximum point should be 1, right? So you have to draw like a curve going upwards, and then the pi, and then at pi it goes down, and then it goes to 2 pi, but like the minimum is -1.
Okay, but where do for what values of x does the minimum and maximum occur?
So x is at 90, wait, at 0 degrees, x is 1.
At 0 degrees or 90 degrees?
Yeah, isn't x 1 at 0 degrees?
For sine?
Sine. My bad. Sine. So at 90 degrees, sine is 1. So at pi over 2, it should be 1.
Okay, so I would rather, to save yourself the pain, sine looks like that.
Yeah.
Right? And it starts at 0, right? And it's perfectly symmetrical, right? So this is 1/4 of the way, this is half of the way, this is 3/4 of the way, this is the full way. So without having to think of the unit circle, if I would immediately go, okay, 0, 1/4 of the max, symmetrical, boom. Okay, yep. I always put them in because I'm a terrible sketcher. And if you ever tell that to anybody else, I will deny it and call you a liar. Okay, so that's y equals sine x. Okay, just as a reference. And maybe you don't even have to do it on the same graph, right? Maybe you just go, wah, right? And you're like 2 pi, just a real rough thing, because then it doesn't get messy. Just a suggestion, right? Okay, however you want to do it. All right, go.
So maybe if you could use a different color, that would be a little helpful.
I would love to. I'm gonna go green or red. Green or red? What do you want?
Green.
All right.
So for our new sine curve, it moves, the whole thing shifts down 1 unit, and then the whole thing also shifts to the right pi by 3 units.
Okay.
And then our new period is pi. Wait.
Yes. Yay!
Yeah.
Look at you. Period equals pi. We're gonna go down 1, and we're gonna go right pi over 3. Cool.
And then 4 is the amplitude. So yeah, the maximum value is 4 and the minimum is -4.
Nope. Because you just told me we're moving down one.
Oh, so if you move down, you'll be at -1. -1 plus 4. I mean, yeah. So the maximum is 3. And then the minimum is -5.
Look at you. Okay.
And then you can draw it now, I guess.
Okay. Now, I know how I would go about it.
Okay.
Like there's so many different ways to go here
Yeah.
and none of them are wrong. So you got to do
Okay.
what makes sense to you and then I'll correct you if you're wrong, okay? So what do you want me to do?
I guess first put a point at 0, -1.
Okay.
And then so
So that corresponds to this guy, right?
Wait, but then it also shifts right pi by 3 units, so
Okay, good.
So that is,
That's about right here, right?
yeah. So it's like 2/3 of the way to pi by 2.
So
Right
is
there.
that my
Yeah, that's the new
actual
starting point.
Yay? Okay,
So
good.
then the max is 3.
Okay, so let me get our dealios here, right? Just make sure we have enough room. 1, 2. Oh, that bothers me that would be green. 1, 2, 3, right? Can you hear me?
Oh, I think you froze for a little quick minute there.
Okay. And so here we go. Good, good, good. Now what are we gonna do?
Okay. So then
Can I make a suggestion? Because I think you're headed down a path that's gonna be a little more complicated than it has to be.
yeah.
Okay, so I agree, get that starting point, right? Get your 0 and find it. Beautiful, right? Now let's do the period. Let's find the end point. So that's going to occur at pi over 3 plus pi, right? So that's actually 4 pi over 3, isn't it?
Yep.
And we know the endpoint is also horizontally equal to the starting point, right? Okay, well, let's see, 4 pi over 3 is where? Like, tell me about where to go on the x-axis to get to 4 pi over 3.
Okay, so somewhere between pi and 3 pi over 2, I think.
Yes.
Yeah. So somewhere between there.
All right, now we're gonna think unit circle in our heads, and you did that so beautifully yesterday, right? So, okay.
Half, 2/3 of the way to 3 pi over 2 degrees.
Yes, isn't that fantastic? Look at you, right? Okay, and so actually I should do a thing. So this is pi over 3, right? And this is 4 pi over 3. Actually, I should put it underneath. I'm sorry. And we know this is the guy, right? Now we are sketching, okay?
Yeah.
We are totes sketching. And if they gave you a blank slate, they are not, it has to be just close, right? Just close. Now, if they gave you a grid, you're going to have the marks there for you. You're going to have everything you need to put it exactly where you need to put it.
Okay.
But we are sketching, right? Some might say it's a bit sketch. I didn't go there. Okay. Now, it's perfectly symmetrical, isn't it? Halfway between, it's going to hit 0 again, isn't it? I'm going to eyeball halfway between. I could do, pi over 3 plus pi over 2 if I wanted to mark it, right? Half of the period. Are you with me there?
Yeah.
Okay, so shoot, so that's 2 plus 5, that's 5 pi over 6, right? So 5 pi over 6 is very, very close to pi, so I blew it a little bit, right? So it's, you know, but just based on where I put the other one, whatever, okay. And then halfway between these guys is the max and the min, isn't it?
Yep.
I'm getting excited about this thing. I really am. So, and I know the max is where?
The max is 3, so in between the first 2 dots, it should be at 3.
Whoop! What's the negative? What's the min?
-5.
Whoop! You got what? All you need is one cycle, really, right? So up. Oh God. I should try and go down. Oh, not bad. The words you're searching for is really good, Dave. I know that's what you're thinking, and maybe you're just a little embarrassed to say it. Okay, so you know, then if you really wanted to, like, you know, it's going down. It certainly isn't going down to -5, is it? No, it's not. So you could, if you want to get the y-intercept, you could easily plug in a 0.
Yeah.
Right? So sine of -pi over 3. So that's, you know, again, on your unit circle, that's down here, right? And so that's what, -√3 over 2 for sine?
Yeah.
Okay, and that's close to, and it's times 2, so whatever, it's, you know, it's about maybe here, I don't know, right? So you sort of have, you know, it's sort of going that way, right? And then here, 4 pi over 3 plus pi is 7 pi over 3, and that's like over here. So you can do the same thing again, right? You can do like, okay, just to sort of eyeball it, right? And then whoop, whoop, and you stop at the 2 pi. Done, 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 done. How about that?
Yep.
Does that make sense?
Yeah, that makes sense.
Because you want to make, you can get bogged down easily on being really accurate when you're sketching, and no, you can't. No one, not everyone can be as good as me with the accuracy in the sketches. That's what you have to realize.
Yeah.
Okay. I say in jest, of course. But I think you get that first point, you get the period, and boom, you're golden. Everything else is symmetrical.
Yeah.
Okay. All right. Would you like to do another one, or do you feel okay about it?
I feel pretty okay about it.
If I put a negative, that was a -4, it would just be whoop.
Yeah, it would flip.
Right? It gets a little weird, but not really if you use this method. If the period is like, I don't know, 5 pi over 6 or 4 pi over 3, right? But it doesn't matter. Like once you find that horizontal distance, start, finish, middle, max, min, done.
Yeah.
Right? Okay. Now, what if, just out of an abundance of precaution, abundance of caution, what if this had been y equals 4 sine of 2x minus 2 pi over 3?
You have to
minus
take
1. What? Yeah.
You have to factor the 2 out.
This, yes, that's got to come out to get the correct phase shift.
Yeah.
Period, you're fine. It's still 2 pi over 2, but the phase shift, not so much. All right.
Yep.
Okay. Now what?
I think he also said there were gonna be like the inverses of each function on the
Oh, you got to graph those.
I don't know if we have to graph those. Let me look at the slides.
Yeah, here, I can share them. I have it up. So notebook and the PowerPoint. Booyah. And can you see the PowerPoint?
I can, yeah.
Okay. All right, so I'm on slide. Yeah, there are graphs here, but so here's sine and cosine, right?
Yeah. I think also at the end of the slides, there's like a list of topics that we need to know for this specific test. Let me look really quickly.
Yeah, I don't see the topics. So the practice I sent you were IB questions. Does your teacher use old IB questions or write his own test?
On the test?
Yeah.
I've for like the level 7 to 8, he might use an IB question, yeah.
Okay. So that's okay. I sent you all past IB questions. I don't know if you looked or not.
Yeah, I do look at them.
And they might be harder. They're harder. They are harder than what you and I have done for sure. But we're getting the bait, we're laying the groundwork here. So.
Okay. So there's on slide 75, I believe there's like a list of things.
Oh, mine only goes to 73.
Oh, really?
So, yeah. So, go ahead and share your screen.
Okay. Will do.
All right. You're good with unit circle. Angle conversions from radians to degrees and degrees to radians.
Easy, yeah.
We know, the inverse trig functions and reciprocal trig functions. Inverse is just finding the angle instead of the right. And then reciprocal is your sine and your cosine. I'm sorry, sine and cosecant. Cosine and secant, blah, 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 blah. Graphs of trig functions, which we've done sine. Now, cosine is the same, like the same rules.
Yeah.
It just starts differently, right?
0, 1.
Yes, it goes, woo, it's ugly, man. I don't like it. Yeah, it's the same exact thing, just shifted, yes?
Yeah.
Same rules. That's all we've done. We have not done tangent, secant, cosecant, and cotangent.
Yeah.
So we haven't done that. I don't know if you've done compound and double angle formula.
I have, yeah.
Have you done solving equations? So then I guess it's graphs of inverses. Is that what you want to do?
I think that would be really helpful, yeah.
All right.
Oh, yeah.
I got it. All right, we will start with tangent. No, we're not going to start with tangent. So there. Because we just did sine and cosine. So looking at what she has done here. She has just done the basics. I don't know about your homework. It doesn't look like there's shifts or anything. Let me see. Like I would have to see what your homework is to see if there's any shifts, but we'll start with the basics and we'll go from there. Okay. All right. So the good news is we don't really have to get a bunch of points or whatever. So as I get to know students better, and I'm getting to know you better, and your sense of humor, you might hear me say some things like totes. And it's just because as I'm drawing this graph, I say it to be annoying. I'm not trying to be cool. I want you to think I'm trying to be cool. Okay, and relate to the younger things. And totes is so old. That's why it's even worse, right?
Yeah. You know, it's okay to admit if you just say it.
No cap, honestly. All right, we are going to graph y equals cosecant x. What is cosecant? And we're going to go from negative, we're going crazy, negative 2 pi.
Also, really quickly, he just like taught us like the inverses like maybe like in 20 minutes at the end of like last class, and he didn't give us any homework on it or like any practice with it. So I feel like hopefully he won't give us like really like, so basically it should probably be like basic stuff.
Yeah, I agree, and that's what it usually is. Evil. That's what it usually is, unless he's evil. Or is he evil?
Unless he's evil, but he is also kind of evil.
Okay, while I'm doing this, I want you to think and be prepared to tell me, where is cosecant undefined? That's what I want you to think. And what does it mean now? I'm not sure if you're struggling or not.
Just thinking.
Okay. I'm still here. I'm getting up for a sec.
Okay. Are there like a few different places? Is it 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees?
When would cosecant be undefined? Not like what? Not no. Okay, let me rephrase that. Forget about your unit circle. Cosecant is 1 over sine, right?
Yeah.
So it's a rational function in a way, right? Meaning it's a fraction.
God, I was taking 1 over tangent for some reason. I was saying cotangent instead of cosecant. So that's my bad. Okay, wait. Okay,
well, it's actually the same thing. It's the same thing because cotangent, sine is in the denominator. Cosecant, sine is in the denominator. When is a fraction undefined? When it equals 0. So all you need is, where is sine equal to 0?
So 0 degrees, so 0 radians, 2 pi radians, and pi radians.
You got that right, Jackson. That's another thing that I say, and I don't know I'm saying it. Because a friend of mine, Shalin, he used to say it all the time in high school, and it stuck with me forever. So if it's undefined, just like other functions, we got some asymptotes, don't we?
Yep,
we got us some vertical asymptotes. And I'm just gonna do this. So at pi, right? At all the multiples of pi. 1, 2, 3, 4. So wonk here. So it's kind of nice to put those in first. Or what, it doesn't matter, whatever your preference is. I don't know if you need to do it. I'm doing it there on the y-axis.
Yeah, I like putting them in first also.
Okay, cool. Okay, so to graph cosecant, since it's the inverse of sine, we are going to graph sine. And that's exactly what he did. Or that's the way he taught it, just looking at your slides, right? So sine looks like this, yes?
Yep.
Oh, that's awkward. Wonk, 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 wonk. And here we go. Right? Red or blue, red or blue, red or blue? Blue, because the things are yes. Yes. Okay, so at pi over 2, sine is 1. 1 over 1 is?
1.
1. It's just a flip. That's all you got to do. And why is it? It's hugging the asymptotes because it's getting closer and closer because it's smaller and smaller and going to negative infinity, positive infinity, and all that wonderful, wonderful stuff. Boom. Done.
That's it.
That's it. Now, he could, like if it was cosecant 2x, right? So period of reciprocal trig functions. And to do that, oh, well, it has the same periods, right? The period here is 2 pi, because one cycle is happy guy and sad guy. They look parabolic, they're really not. They're more like, it should be more, you know, it should follow the sine curve better than I did, but I don't think he cares. Especially if you're sketching. Okay. Okay. All right. So cosine is the same, just shifted. Right. So if I duplicated this guy and oh, this is going to be so much fun. So I'm going to do everything except for let's see if this works. Ready? That's all right. Oh, no, I can't. Okay. So if I just did, let me get rid of this. Okay. So if I just move my axes, right? Where is cosine undefined? Well, it's defined at the pi over 2's, isn't it?
Yeah.
Right? So oh, the things aren't going with it. Gosh darn it. I don't have my points going with it. So I can't duplicate this.
Okay.
Okay, so boom. So this is pi over 2, right? Pi, 3 pi over 2, 2 pi, and so on, right? So bonk, 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 negative 2 pi, negative pi. All I'm doing is moving these guys. I'm going to a lot of trouble when I could have just sketched the thing from scratch. But I wanted to emphasize the shift. It's just a shift, isn't it?
Mm-hmm.
Right? Okay, and so what does the cosine curve look like?
It starts at 0, 1, and then it goes like down from there.
Good. So 1, negative 1, so wonk, wonk, right? And this guy's out of the picture. Whatevs. Okay, so it looks like this, right? Ooh, it seems harder to draw than the sine curve. I'm not sure why.
Yeah, I've
Sort of
noticed
weird.
that.
You know, it's like, I don't know. It shouldn't be. Like, okay, so maybe you just do an imaginary. Okay, now it's okay. You start off with sine curve. Okay, so that's cosine, right?
Mm-hmm.
So y equals secant x, same exact thing. Right?
Yeah.
There you go. Now you do need to do this part if we're going to do a full, right? Because it's from negative 2 pi to 2 pi. So it's green.
This makes a lot of sense, yeah.
Yep. Tangent, not so much.
Oh.
Not as nice. It's not bad. It's just, we don't know tangent, right? But once you know it, it's like a cubic. So that's kind of nice.
Mm-hmm.
Okay, so now you have to tell me while I'm just putting in the thingies here. You're in charge of where is tangent undefined. We had a little hint earlier, sort of, I don't know.
So isn't it just like 90 degrees and 270 degrees?
Yep. Sine over cosine, wherever cosine is 0, right?
Yeah.
So it's the same as secant, right?
Mm-hmm. Yep.
Now I want you to tell me where tangent is equal to 1 and where tangent is equal to negative 1, okay?
Mm-hmm. So tangent is equal to 1 at 45 degrees, so pi by 4, and then
Pi over 4, right? Oh my, look
yeah.
how terrible this is. I gotta move this. The symmetry is terrible.
And also 5 pi over 4. Oh, but we don't. Wait.
Yeah, we do.
Yeah, 5 pi over 4 also.
I'm just trying to get the symmetry the same. For my horrible markings. Okay. So this is pi over 2. Here's pi, negative pi. Here's negative 2 pi, right? Negative 3 pi over 2. God, that's terrible. I'm sorry. All right. So you just told me that at pi over 4, tangent is equal to 1, right?
Mm-hmm.
So that would be here, wouldn't it?
Mm-hmm. Yep.
Okay. It's also equal to 1 at
pi over 4.
5 pi over 4.
Yeah.
Right? And it's equal to negative 1
At
negative pi over 4, right? And here, isn't it?
yeah, it's equal to negative 1.
At 3 pi over 4 and 7 pi over 4.
Yeah.
I put a little bonus one in there. And it's equal to 0 at 0 at pi and 2 pi, right?
Mm-hmm.
Okay. And it looks like John Travolta. Wait, is dad laughing? Did I hear dad laugh?
Yeah, that was my dad.
Listen, it's gold if I get dad laughing, just like a cubic, right?
Yeah.
Same thing. Now, forgive the symmetry. It's embarrassing, but I sketched it. There we go, right?
Yeah.
It's just Travolta. And we could get into, I think you're smart enough to realize, though, that the closer we get to these asymptotes, right, it's smaller, negative, right?
Yeah.
Okay. All right. And so then once you see this pattern, it's like, oh, okay, it's the same pattern. Yep.
Mm-hmm.
Off we go. Right. And you cannot unsee Travolta. Am I right? You can't do it. You can't do it.
Yeah.
I don't think she understands John Travolta, who that guy is. So
do you know who John Travolta is? Okay, that's part of your homework assignment. Saturday Night Fever. It's rated R, but you'll see Travolta. There'll be a picture. He'll be like this.
Okay.
In a white suit. It's a horribly great, horrible movie.
Okay.
That your dad and I endured. Okay. Are you good there?
I am, yeah.
Okay. So what do you think about cotangent? What are your thoughts?
It's not bad.
No. This is tangent.
Oh yeah.
This is the graph of tangent. So I guess bad teacher. What do you think about the graph of cotangent? It is the inverse of tangent.
Yeah.
So, okay. So remember when we had,
Is it gonna go the other way?
Yes. Instead of, it's Travolta in the mirror.
Yeah.
Right?
Yeah.
However, is tangent undefined in the same places that cotangent is undefined? No. So there is a shift and a flip, isn't there? But that's hard to remember. So the way that I encourage students to remember is just quickly plot where tangent is equal to 1 and negative 1. And you only need to do it in one space because it's the same, right? Yeah. And then also do the same for where cotangent is -1. Okay, so let's just make sure, right? Okay, so you're going to be thinking about where it's undefined as I'm making these awful increments here. 2 pi, pi, bonk, bonk, -2 pi, -pi, -pi/2, pi/2, -3 pi/2. Jeez. And all right, where am I undefined?
0 radians, pi radians, and 2 pi radians.
Which is the same as secant, isn't it? No, or no, cosecant. Because sine's on the bottom, right?
Yeah.
There you go. Okay. You don't have to worry about the zeros anymore because they're halfway between the asymptotes. Make sense?
Yeah.
Boom, boom, boom. Now, if you have tangent memorized, then you can do cotangent immediately. But let's just pretend that we don't, right? Cotangent is equal to +1 cosine over sine at pi/4. Same thing as, it's the same as tangent, right?
Yeah.
Right? We're done, aren't we? Like, we really don't have to do anything more. Maybe you want to put in some, you know, some points to shoot for, and off you go. Travolta in the mirror. I can't do it. It gets embarrassing if I don't have. And so on, right?
Yeah.
Forever and ever and ever and ever and ever. There you go. So I would argue the reciprocal functions are easier to graph. If all you have to know for sine and cosine, for sure, right? Because you just do a sketch of sine and cosine and you flip them. Now, if he starts doing different periods and phase shifts, it gets a little dicey. But again, once you get the period and the 0, that's the same thing, right? Or the undefined, I'm sorry, I should say the undefined points, you're off and running because it's just between the asymptotes, and then you just move whatever. Okay.
Yep.
All right. So those are the basics of all of your trig graphs. I'm sure I'll have you move cosine and sine around, but based on what I've seen, he's a mean person if he does that with the, if he hasn't spent any time on it. So. All right. So what do you want to take a look at? We've done, you say you're comfortable with everything that you showed me. You have a law of sines and cosines, solving triangle type problems. You're okay with that? Like slide 71?
Slide 71. Oh, the law of cosines and sines, that's not going to be on this test.
Oh, okay. So it's just the graphing.
Yeah.
Okay. So, well, then I thought it was everything. Well, I gave you practice for everything with IB questions. And if it's just graphing, then I don't know. There's not going to be IB questions, I don't think, unless you have to graph to model something.
I don't think so, yeah.
Okay, so he hasn't given you data where you have to come up with a sine curve that fits the data? Okay. So it should be straight up graphing.
Yeah.
Okay. So then what would you like to do with our remaining, we have 10 minutes remaining.
Inverse functions you are comfortable with?
Huh?
Inverse thetas, you're good? You can ask him if you have any questions.
Like inverse problems?
Yeah.
Finding the angles.
I think so, yeah. If you have any problems like with that.
Sure, let me, maybe I'll look at what I sent you. See what we got.
Hey Dave, before that, I just want to ask you a couple of things. I think this Tuesday is this trigonometry. She is very, I think, almost there. She is comfortable. She's done a lot of examples and all those questions. And next Tuesday, not this coming Tuesday, but Tuesday 1 week after that, she has a quiz on series.
See, I have a retake on sequences and series.
Oh, okay.
So I know like we have a class on Sunday for sure, but if possible, I think would like to have some class middle of next week, Tuesday or Wednesday. I think I know you're a busy person, so.
Okay, let me take a quick look at what next week looks like. How early can you start? Vaish, sorry. Vaish.
It depends on the day that you can tell. Like
I think it depends on the day. Like we can start Tuesday.
No. Like, how soon are you home and ready to have a session?
How soon am I home?
After school.
After school on Tuesdays through Thursdays, I am home after school at like 3:30.
Okay. Any earlier? Well, yeah, because I have a 3 to 4 available on Tuesday and Thursday. And that is about it. Yeah, that's it. My week is jam-packed. So
yeah,
we could do, at the very least, we could do 3:30 to 4 on both Tuesday and Thursday. And then I get cancellations from time to time. Actually, no, I'm sorry. I'm going to get back to you. I'm either going to have a Monday at 8:15 or 9:15. I'm not sure which one.
Okay.
Slot available.
Okay.
Or a Wednesday sometime after 7 available.
Okay. Yeah.
I think Wednesday sounds like a good thing.
Yeah, Wednesday. I'm always here on Wednesdays, but just let me know. And
okay. I think it's more likely the Monday than the Wednesday. I have a client who's going from 2 times a week to 1 time a week.
Okay.
And we're not sure which one he's going to keep. So that's what's coming open.
Okay.
He's leaning towards keeping the Wednesday.
Okay.
Right. So, but I will hammer that out, and I'll let you know. I'll text you or whatever.
Okay. Thank you.
Is that good? Okay. Okay. Where were we?
Inverse.
Yeah. Practice.
I think maybe you can just teach her the basic concepts of the inverse. I think she gets confused with like when we say tan theta is equal to say half. When you say arc tan inverse something.
Got it.
I think those concepts. I think maybe just go through that. I think that'll be good. I think so.
Okay. Okay, let me get a unit circle. Our good friend, your favorite, I know. You got it very quickly, though. I got to say, pretty impressive.
Thank you.
And I like the way you think about it. I can see you picturing it in your head. That's really good, right? And then, of course, this is very important. That's not actually John in the movie. It's like a costume. All right.
Okay.
That's John Travolta.
Okay.
All right. It's a dance movie. Okay. So, so if I asked you, what is the sine of 5 pi over 3?
Okay, 5 pi over 3, so that's the 60-degree family. 5 pi over 3 would probably be...
Probably be?
5 pi over 3 would be in the 4th quadrant.
Yes.
So 60 degrees there is...
Yes.
So the sine would be negative root 3 by 2.
Outstanding. So these guys are linked, right? And remember, sine, cosine, it all goes back to the right triangle. Yeah.
Yeah.
So what we're saying is if this angle is 5 pi over 3, right? In a right triangle, it will always, 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 always have the ratio. And I'm getting rid of the negative for now.
Yeah.
Because links are positive, but it would be root 3 over 2, right?
Yeah.
Okay. Always, no matter if this angle goes through Travolta's legs, no matter what, the ratio, they're going to be different numbers here.
Yeah.
But the ratio is exactly the same.
Yep.
Okay. That's why it works. Right? Okay. So root 3 over 2 is forever linked with 5 pi over 3 or 60 degrees. And vice versa. So we have hammered this into you, and I think maybe we should do it at the same time. So it's not, you don't think this linear way. It's hammered into you. Sine of pi over 3 is this number, right? So if I ask, what is the arc sine of, and I should have, let's do pi over 3 just to be, instead of 5 pi over 3, just to make it positive, okay? If I say, what is the arc sine or inverse sine? I wish we would always just say arc, but of root 3 over 2, it's a question. This is the question. What angle has this ratio? What angle has this sine ratio? And that is 60 degrees or pi over 3.
So it's like the same thing, basically.
It's the same thing, but instead of asking what's the sine, this is asking what is the sine of this angle? What is the ratio, the sine ratio of this angle? And the sine ratio of this angle is the square root of 3 over 2, right? Now, the arc sine is giving you the ratio. And you just agreed with me that the ratio is the same. This only has one guy, right? Monogamous, right? It's 60 degrees. That's it, forever and ever. And in radians, that's pi over 3, right?
That makes sense, yeah.
Okay, so when we have our triangles, and I'll just go with right triangle trigonometry, but it works for all triangles because it's about the angle, not about the sides.
Yeah.
But it makes more sense with right triangle trigonometry. So I don't know if this is 4 and this is 9, right? And this is A. I got to find A. Well, I know like we're taught, okay, I know that the sine of this angle equals 4/9, right?
Yep.
But to find A, and we don't write it this way, but we're saying that we're asking the inverse sine of 4/9 is equal to A.
Yep.
Right? Now we write it like this, A equals the inverse sine of 4/9, right? Okay. So your calculator has that for you.
Yep.
Right? Your calculator has that for you. So just to be the guy, and this is for your father's benefit as well, in the back of our textbooks, even when they started to have calculators, these were still there. We had these tables where these decimal ratios were there. So we had to find the decimal, right? And let's say we're finding the inverse cosine, and we had to go 0.9336. Oh, that is 21 degrees. Like we had this whole horrible nightmare.
We don't have calculators at the time.
That's right. But remember when the calculators first came out, the old school teachers still made you use the table. They go, what do you do if you don't have a calculator? I would say, I'd go buy one. Right? I mean, what are you talking about? So, and then, oh my God, Vaish, we would, sometimes it would be like, it was never exactly the decimal, like it would be like here, right? It would be 0.9357, right? And so then you'd have to interpolate to get an accurate point whatever for the degree. Forget about the radians. That was a nightmare. Okay. Yeah. So we also walked the school uphill both ways. All right. The whole thing. Anyway, so the calculator, actually, I'm not doing that just to be funny. The calculator has all of this stored for us. And that's what's happening. You say, all right, what angle has a ratio of what, whatever. Well, the calculator says, whoop, okay. So the tangent ratio is this. There's the angle, right? And we also only had 1 through 90. And then we had to figure out by quadrant if it was positive or negative and which angle it was, and the whole nightmare. So anyway, okay. So I will let you know as soon as I find out which day and the time, and then I'll give you a range, and then we can work it out that way.
Yeah, sounds good.
All right. Okay.
Thank you so much.
I'll send you the notes, and the video posted in about an hour or so.
Okay. Thank you so much.
Be good.
Good day.
Bye.
Thank you.
Yep.